Hey, we're back in the application lab here at Runcorn, UK with a focus on chromatography workflows. We're talking with Dr. Tony Edge, Technical Manager here in the application lab. Tony, talk to us about this particular setup in the application we're looking at.
I'm really excited about this. I worked with this technology a couple of years ago, and what it allows you to do is analyze plasma directly, a real biological fluid. It's not been possible before within the scientific community to actually analyze plasma. So what actually happens is that you take a standard order sampler, this is a modified CTC, and you inject the neat plasma or neat biological fluid into this section here. And then what happens is that it goes through the selection of valves onto the TurboFlow column. So the whole technology is based around the TurboFlow column technology. And it really does allow you to get these leaps and bounds in terms of productivity gains. By not having to pre-treat the sample, it means that you can actually directly inject. So now we've got the sample going onto the TurboFlow column, which is the first part of the engine to the whole system. And what that does, it removes the bulk of the matrix. So we start off with plasma, which has tens of thousands of different components, ranging from salts to proteins to peptides to a range of components in there that you actually want to look for. What then happens is that after it goes through there, we remove the bulk of these larger molecules and some of the salts, and then we pass it on to really, if you like, the petrol within this V8 engine that we've got. And this here is the thermo product that really does drive the productivity gains. What we've got here is a HPLC column which uses sub-2 micron particles. The advantage that that has is that it allows me to run very, very good separations, very efficient separations. So I can actually separate components which previously I might not have been able to separate just by using the sheer power of that chromatography. And so by separating these components, it allows me then to start studying isobaric interference. That is, compounds that potentially have the same mass that I'm co-eluting from my column, which previously I've not been able to do. From here, it then goes into the mass spectrometer, and this is the latest mass spectrometer from Thermo Fisher Scientific. And what this allows us to do is really start to analyze very, very low sample volumes, which in the field of clinical analysis and also pharmaceutical analysis is really critical, because what it allows us to do is actually take smaller sample volumes. So one of the big issues in the pharmaceutical industry at the moment is the uses of animals. Animal usage is a particularly hot topic, and it would be great if we could actually reduce the number of animals. However, the amount of samples that is required to be taken from an animal can't diminish until we improve the sensitivity of the detector, or until we can actually start injecting neat biological fluid. This whole system allows us to do that. The key to it though is really getting the separation here, which then allows the detector to do its business. And then if we kind of wrap this all up, we've then got the software which allows us to take those individual components, detect them, and then quantify them. So what we can now do is we get that data out in a format that is very, very usable by the customer.
See more innovative solutions for your toughest analytical challenges at thermoscientific.com.